In this video, we're going to talk about how to find the percentage composition of a compound. In our last video, we learned about how to find the molar mass of the compound. In other words, how much a compound weighs, or that may be the wrong term, the molar mass. So if you haven't watched the last video and you don't know how to find the molar mass, you may want to go back and watch that video or perhaps review it. So to find the percentage composition of an element in a compound, what part of a compound is its mass, what part of it is attributed to a particular element. First you have to find the molar mass of the entire compound, and then you divide the mass of the particular element by the mass of the entire compound, and then you multiply by 100 to get the percentage. This is really very similar to what you've probably been doing for years. You get a test back and you want to know, well, what percentage did I get on the test? So you've taken the part, your score. Why don't I write this in here? You take your score, and you divide that by the maximum, what you could have gotten, the possible score, which would be like 100% if you scored everything perfectly. And you do the division, and once you've got your answer, you multiply that by 100, and you have your percentage, your score. And this percentage composition with molar mass and elements, it's really the exact same process. So let's go to the next slide, and I'll give you an example of what we're talking about here. Let's say we wanted to find the percentage of chlorine in lead 2 chloride. So we have this compound, lead 2 chloride, and the first thing we have to do is find out how much does the whole thing weigh. So lead, from the periodic table, its atomic mass is 207.2 atomic mass units, or grams. I'm just going to use grams, it's a little easier. And the chlorine, each chlorine atom has a mass of about 35.5 grams. Now we have to multiply that by 2 because there are 2 chlorine atoms in here. So we've got the part that's lead, the part that's chlorine. We add those together and we have the molar mass, or in other words, how much one molecule of lead 2 chloride is. It's 278.2 grams. Now we wanted to know what part of this was chlorine. So the chlorine we found weighs 71 grams. So we're going to take that 71 grams, divide it by the mass of the entire compound, 278.2, and we get this decimal. It's 0.2554 is the decimal. Now we multiply that by 100, and we come up with that the part that is chlorine is 25.5%. Now, it's not asked here, but if you wanted to know what part of that was lead, there's actually 2 ways to do this. Now, the entire compound, if you have the whole thing, that's 100%. So if we were to simply subtract this from 100%, we would come up with the lead portion is, let's use a different color here. We subtract this from 100%. Just squeeze it in there. We subtract that, and we come up with whatever's left over has to be the lead. So the lead is going to equal 74.5% of the compound. Or that's one way to do it. If you only have 2 elements in a compound, you can do it that way. It's pretty easy. Or you could go through this same process again. You could take the 207.2, which is what the lead weighs, and divide that by how much the entire compound weighs, and that would give you another decimal. It should give you, take these 2 right here, and you do your division, and you should come up with 0.745 approximately. And when you multiply by 100, it's just the same as moving your decimal over 2 places, which will give you about 74.5%. So you can do this either way. Now, if you have more than two elements in a compound, you're going to have to go through this process for each one of them. Okay. Here we have a situation where we want to find the mass percentage of water in this hydrate. This copper sulfate, and you have 5 water molecules attached to it. So if you find out the entire mass of the whole thing, including 5 waters, so when you did, you would have 10 hydrogens, and you would have 5 oxygens plus the 4 oxygens here would be 9. Okay, you'd have the mass of the entire thing plus the copper, and you're going to divide that by how much this part here weighs, and it should give you a decimal. You multiply that by 100, and you should come up with 36.08% of this entire thing being water. Okay, I'm going to do one more example, and then we're going to call it quits for this video. Okay, we want to find the percentage composition of barium nitrate. Now, when it's worded this way, what we're looking for is what percentage of this thing is barium. We're looking for what percentage of this compound is nitrogen, and what percentage of this compound is oxygen. Now, a good check, I mean, after you go through and go through the steps, find the molar mass of the entire compound and how much each part weighs, which you have to do anyway to find out the whole mass. Once you're done and you get a percentage for each one of these, they should add up to 100%. If they don't, it would be a great idea to go back and look, because you probably made a mistake somewhere. But anyway, after you do all your calculations, you should end up with right here 52.55% barium, 10.72% nitrogen, and 36.73% oxygen. Okay, be careful about rounding too much. Going to try and be accurate to at least a decimal or 2 decimal places. Round them there. And after a couple examples here, you should be pretty good to go on this.